Welcome back everybody, and today we're going to be having a look at Siemens System Function Blocks, or as they like to call them, SFBs. Now before we actually get into the video, what I'd like you to do is like the video, comment below, and then if you're watching us on YouTube, hit the subscribe button. I don't really care what you hit it with, just hit it. Anyways, let's get back to today's video. So last week we had a look at Siemens Counters inside of STEP7 Professional, and we really highlighted the reasons why we don't use those counters inside of our programs when using STEP7 Professional. And the reason for that was because they didn't really work like Siemens Counters should. We showed you how they worked inside a TIA portal and how they work in other PLCs. However, when it comes to STEP7, they work slightly different. Now Siemens does have another set of counters inside of STEP7, and those are inside of what it calls the SFBs, the System Function Blocks. These are actual function blocks that are being created by Siemens and are then stored onto the CPU of the PLC, meaning that when we use them, we don't have to actually download them to the PLC, they're already on that PLC. Just like any other function block inside a STEP7 or TIA portal that we use, we must always assign an instance data block to that. And we're going to be showing you how we can actually use them inside of programs, how to set them up, how to create the instance data blocks, and then how to get them working inside of a PLC program. Let's get started. So if you look at my project at the moment, you'll already see OB1 available, and then you'll see 6 other blocks, and these other blocks will be SFBs. And you'll notice on these blocks there's little padlocks. This is because it's being created by Siemens and these cannot be altered by us. We can't go inside of these blocks and start altering the code. They are fixed, and like I say, they're already on that CPU. Now if I just try to open up an SFB, this block is protected and you can't see anything there, and that's the same with all the other SFBs. Now what I'm going to do here is I'm just going to delete these SFBs from this program, and we're going to start afresh. Just say yes to that, and we're going to open up OB1 to start with. Now inside of OB1 we've got a blank program so far, and if you look on the left hand side where your instructions are, there's your counter folder, and we also have our timer folder just below that with the Siemens 10 timers available. Now just below that you'll see some other folders labelled function blocks, functions, SFBs and SFCs, and if we just open these blocks, you'll notice that there's nothing inside of them. When we start to create these SFBs and SFCs, or just function blocks and functions inside of our programs, we actually start to add it to the ladder, that's when you'll see these folders start to be populated with the blocks that we're using. To the basic user of STEP7 Professional, a lot of people don't even know that these system function blocks exist. To locate where these system function blocks are, all we have to do is open up our libraries folder, open up standard library, and then inside of there, about midway through, is your system function blocks folder. Now if we open up system function blocks, this is where all of the system function blocks are located. Here you'll see the first 6 are your counters and your timers, and these counters and timers are very similar to what are inside of TIA portal at the moment. If I just open up TIA portal here, and then we go to our timer operations, there are the timers that Siemens have created inside of STEP7, excluding the TONR. And if we open up the counter folder, there are our counters. Now if we just go back to this, you'll notice next to these names here, CTU, CTD, CTUD, etc., is IEC. This is part of the programming standard IEC 61131-3. These are IEC counters and IEC timers. What this means is we can actually create these blocks inside of Siemens STEP7 Professional, and we can then convert that program to another PLC, and it will convert over with those timers as they are designed to the IEC standard. The other counters and timers that Siemens use in these folders, if we use those inside of our programs and we try to convert that to another PLC program, it wouldn't convert correctly because those timers and counters might not be available in another programmer. However, these CTU, CTD and CTUD and TP, TON and TOF blocks are. These are IEC blocks. And these are the blocks that we're going to have a look at. You'll notice that there's quite a few other blocks as well. We're not going to get too involved with these other blocks right now as they're a bit more advanced. All we're going to be able to look at is the most commonly used ones, our counters and our timers. Now these work just like they do inside a TIA portal, so I'm not going to go too much into the actual functionality. We're just going to start adding to our program, set it up, and then get them running. So the first thing we're going to have a look at is our CTU. We looked at counters last week and why we don't use them. Well, let's have a look at how this CTU works and if it works just like it does in TIA portal. So I'm just going to drag my CTU to the PLC program, and you'll notice when I first drag that block over, there's question marks at the top of the block. This question mark isn't referring to giving it the counter number or giving it a timer number or anything like that. This is referring to a data block. Whenever you create a function block inside a Siemens, you must assign a data block to it. This is its instance data block. And what that instance data block does is when the PLC executes the code for that counter there, it stores the results from that counter into its data block, and then it can refer to that later on in the program. We can also access that data block and use it in the program as well. Now let's assign that data block to DB1 and then select enter, and you'll notice when we select enter there, it pops up with another dialog box, and that there states this instance data block DB1 does not exist. Do you want to generate it? I'm going to say yes, and what that does, it allows the Siemens STEP7 Professional programmer to create that data block. If I just save this and then close OB1 down, you'll now notice inside of Somatic Manager, there is my SFB0, which is the counter up function block, and there is my DB1. If I change the view to a detailed view, you can actually see the name of the function block labeled as CTU. That there is our counter up function block. So if you ever do see these SFBs and you're not sure what it's referring to, just click the details window pane, and that there will change over the view to its detailed view, and there you can see the actual symbolic name being a CTU. I'm just going to go back to small icons as that's what I prefer. Now, if we open up OB1 again, you'll notice on this function block, you've got several inputs, just like our TIA portal program. You've got the CTU here, you've got the CU, which we're going to tie to just an M bit, and we'll use M0.0. You've got the R, which is your reset, and we'll tie that to M0.1. You've got the PV, which we'll tie to 6. And you got your Q, which we'll tie to Q4.0. The CV isn't needed. We don't have to have that CV there. That's just your current count value. What we could do is we could store that inside of a memory word or whatever, and then use that on an HMI or a SCADA system so that the operator could see how much this counter is already counted if it's needed. What I'm going to do now is I'm just going to save my work, and then I'm going to download this to the PLC. Now, if you remember how counters worked previously inside of STEP7, as soon as we triggered the count up signal, it would begin counting straight away and the output would turn on straight away. That's not what we want. What we want is when this count up signal has been triggered 6 times, I want the output Q4.0 to turn on. Hit the glasses, go online, and you'll notice when I went online there, it's currently in stop mode. And if we look at my PLC, it's currently in stop mode and the system fault light is on. Now there's a reason for this, and the reason is this data block hasn't been loaded to the PLC. The function block's already in the PLC, but the data block isn't. I can't just download OB1 and not download the data block, as the PLC is now saying, well, where's this data block? I need to store this information in that data block. So what I'm going to do is I'm now going to come offline, and then I'm going to close down OB1, and I'm going to do a full download, which will download this data block here. To do that, just click the download icon, say yes to all, load the system data, yes to that, restart the PLC, and now when I go into OB1, and I go to goggles, it's now live. And if we look at my PLC behind me, the system fault LED is no longer on and we are in run mode. Remember, when we create a function block, it asks you to create an instance data block alongside it, that data block needs to be downloaded. So let's have a look at this. What I'm going to do here is I'm just going to right click M0.0, modify it to 1, and the counter counts 1. I'm then going to 0 my counter, trigger it again, and it will count 2, 0 it, trigger it, 3, 4, 5, 6. And when we hit 6 inside of this counter, my output Q4.0 turns on. And that's it. That's your counter now working like a counter does in any other PLC. Now to reset this, I'm just going to reset my CU back to 0 and then trigger the reset. And when we do that, my counter goes back to 0, ready to start again. Now if I just come offline on OB1 and close down OB1, now if I open up my DB1 and just select yes to that, you'll actually see my DB with the inputs and the outputs as well as a stat. Now this is all to do with function block declarations, internal declarations inside of function blocks, and we actually cover that on our Siemens programming series online. So I'm not going to go too much into that, but if we look here, we can see there's our CU, there's our R, there's my PV, there's the Q, CV, and there's my internal register. Now what I'm going to do is I'm just going to open up OB1, minimize this a little bit, open up my data block, minimize that a little bit as well, and what I'm going to do here is just go back online, and now if I modify this to 1 and I go online in my goggles here, you can actually see there's my input CU, the count up signal, on. My reset is currently off, my PV is currently set to 6, which it is, the output is currently off, which it is, and if you look at the CV, which we haven't assigned, it's currently 1. If I then just 0 M0.0, you can actually see it then turn to false. Trigger it again, and you'll now see the counter count to 2. 0 it, turn it on again. 0 it, turn it back on. 0 it, turn it back on. 0 it, and then finally turn it back on once more. You'll see it hit 6, and now the output has turned to true. You'll notice this stat operating as well whenever I trigger the CU. That there is internal to the function block. We don't see it on the actual function block here. It's inside of there, inside the actual code. Just 0 that, and then trigger my reset to send the whole block back to 0. And that there is ultimately what an SFB is. It's a block that has been created by Siemens to do a certain task. It's then locked up so we can't modify it. We can then add that to the PLC program and then assign it to a data block. When the PLC executes that block, it then stores the information in that data block and then pulls back from that data block on the next scan for the next operation. Now what I'm going to do is I'm just going to close down DB1, expand OB1 a little bit more, come offline, and I'm going to create another network, and I'm going to add in another SFB0, another counter up. Again, it'll ask me for another data block. Now I can't assign this to DB1 because we're already using that in the PLC. That would be essentially duplication. What I'm going to do here is I'm going to assign it to DB2. And again, it'll ask me, do you want to create it? And I'll just say yes to that. And what I'll do here is I'll use M10.0, M10.1, and again, I'll count to 6. I'll use the next output available, and I'll just leave my CV blank. I'll save that. Again, I can't download from OB1 because I've now created another data block. What I must do is close OB1, download it from Somatic Manager, and download all of the blocks. Say yes to that, say yes to that, say yes to that, and then go back to run mode. Now if I open up OB1 and just minimize that block so we can see both networks, I can then go online here, And then if I open up DB1 and say yes to that, I can then trigger my DB1. And if I just go online, you'll see the live value of that data block. And I'll just zero that. But if I trigger my second counter, the one that's registered at DB2, and I say modify to 1, you'll notice nothing happens inside of this data block. This is actually activated inside of data block 2, so it keeps it completely separate. So if I just close this down here and open up DB2 now and say yes to that, and then I open up my OB1 again, and then go back online with DB2, you can then see the current state of that block. So again, as I add function blocks to the program, you assign data blocks to it, the PLC then stores that data from that function block inside of its relevant data block, and then we can access that later on if we wanted to. I'm just going to close that down. So that there is an SFB inside of the PLC, and that there's your counter up. Let's just have a look at another SFB, and we're going to have a look at a timer this time. If I open up standard libraries and then I go to system function blocks and then I open up TON, what I'm going to do again is assign another data block. Now I can't assign DB1 because currently it's being used for my counter even though I've deleted it, but I can assign DB3. Say yes to that, give the input to this M0.0, set the time value to T#10S, and then set the output to Q4.0. You'll notice I'm no longer using the S5 T-hash, I'm using the T-hash identifier, and this is very similar to TIA Portal. In TIA Portal, you don't use S5 T-hash like you would do on these timers over here. You use T#10S, and again, this is because this is an IEC block. An IEC block is meant to be able to be used in all PLCs. If you start using S5, which refers to the Siemens S5 PLC, then using it inside a Mitsubishi wouldn't make much sense. So we use T#10S. Now what I'm going to do is I'm going to save my work, close OB1 down. I could then effectively delete DB1 and DB2 and SFB0 if I wanted to. It's not being used in my program, but I'm just going to leave them there. Download that to the PLC, say yes to that. Say yes to that, yes to that, and yes to that, yes to that, and then yes to that, and then yes to that. A lot of warnings, a lot of warnings. Open up OB1, go online, and then what we want to do is open up our DB3 block this time. Say yes, minimize this, just shrink down our OB1, go online with this data block, and here are my actual values. And what I'm going to do is I'm going to trigger M0.1, and then you can watch your timer running. And off it goes. 1 second, 2 second, 3 second, 4 second. After 10 seconds, Q4.0 will turn on. And there we go. Q4.0 is now on, and then that output there is on inside of the program as well. Close that down and then expand that. This here, like I say, are SFBs inside of Siemens, and they give your program a little bit more power than old timers and counters would that you would use on the S5 PLCs. On the S5 PLCs, this sort of stuff didn't exist, but when Siemens created S7 300 PLCs and S7 400 PLCs, this is when the IEC standards started to come into place, and this is what they began to create, was these IEC blocks that could be used on any PLC that were universal to any PLC. As I mentioned, I didn't want to get too involved with SFBs. I don't want to go through all of the other blocks that are available. I don't want to also have to go through counter downs and counter up and downs or the other timers, as we've already spoke about those in previous videos. I just wanted to show you how SFBs are created inside of STEP7, how we assign them to data blocks, and how they are then used inside of the PLC. Now, one thing you've got to watch out for is the current version of your PLC. If you're working with the earlier versions of the S7300 PLCs, you may not have the full selection of SFBs and SFCs that are available inside a Siemens, and that's because you work with an earlier version. It's already preloaded with its information. If you're working with newer PLCs, chances are they've got the majority of the blocks that are being created by Siemens already preloaded on its PLC. If it doesn't, there are things called firmware upgrades which allow your PLC to get the newest software loaded onto it, which may include the new SFBs and SFCs. But it's just something to watch out for. If you don't have the full selection of SFBs and SFCs, it could be the firmware version of your PLC is slightly outdated, it's no longer the newest version going. And that there is system function blocks inside of the STEP7 PLC. Now if you want to learn more about STEP7 and TIA Portal, what I'd recommend you doing is going to our website www.scantime.co.uk, going to our e-learning page and then having a look at our Siemens STEP7 Professional, or if you're interested in the newer software, TIA Portal. We also have Allen Bradley on there as well as some generic PLC and SCADA courses to teach you the correct ways of writing programs in today's industry. I hope you've enjoyed this video on system function blocks inside a STEP7 Professional, and I look forward to seeing you again next week. See you later, guys.